Hello children, proposition 14 of book 1, Euclid. Cool problem. If two straight lines come together and meet a third straight line at a point on opposite sides of that straight line, making adjacent angles, adjacere, that come together, they're side like houses that are adjacent, they're right next to each other, make adjacent angles equal to two right angles. Those two straight lines are with each other in a straight line, with each other necessarily. Okay? So let's look at this. If two straight lines come together and meet a third straight line at a point and make adjacent angles equal to two right angles, this angle plus this angle being equal to two right angles, this angle plus this angle being equal to two right angles. If that happens, those two straight lines are in a straight line with one another. Very cool. What? You don't think so? Okay, Mr. Smarty Pants. Let's say they're not in a straight line with one another. Let's say that that's not in a straight line. It's obvious to my imagination. Oh, you want to see it with the intellect? Okay. Well, listen, Mr. Smarty Pants. Will you grant that at some point, of all the infinite number of lines you could continue from that point, at some point, one of them will be in a straight line, right? So if this is up and this is down, at some point, one of them will be in a straight line with it. Good? Okay, great. So let's do that. Let's say, for now, let's say it's this one. Continue this in a straight line. Is that okay? Because it's either going to be above this or below this, right? Let's say below it. So let's say this is one continuous straight line. Hey, look, on this straight line, we have another straight line falling upon it. We know from our bag of knowledge, if there be a straight line falling on another straight line, it necessarily creates two angles, adjacent angles, equal to two right angles. So we know that it must be the case that this straight line falling upon this straight line, supposed straight line, makes adjacent angles, see how these are adjacent, equal to two right angles. Well, look, it was given that this angle plus this angle are also equal to two right angles. Two things equal to the same thing are equal to each other. So it must be the case that this angle plus this angle are equal to this angle plus this angle. Let's take away equals from equals. We'll take away that from both sides of the equation. And now we know that the remainders are equal. That is to say, this is equal to this. But this is also the whole of this part. This is a part of this. See this big angle? This is a part of this big angle. We know that the whole is greater than the part. That is to say, this is unequal to this. Boom! We just reached an absurdity granting Mr. Smarty Pants' position that this line is not in a straight line with this line. We said, okay, let's put one below. Well, if we put one above, then we reach an absurdity. If we put one above, we're going to have the same problem. We're going to have things being equal and not equal at the same time in the same respect. Not even Mr. Smarty Pants wants to say that. So Mr. Smarty Pants doesn't want to say that this is true. It's false that this could be in a straight line. Also with this. Also it's false that another line up here could be in a straight line with this, because that's going to come to an absurdity as well. So which line do we have? Only this one, and this one are in a straight line with one another because they form adjacent angles equal to two right angles, which was to be demonstrated, or in Latin, quod erat demonstrandum. Thank you. Bye-bye.